Hi, welcome to this Corbettmaths video. In this video, we're going to look at how to find the inverse of a 2 by 2 matrix. So if we've got the matrix A, its inverse is shown as A with a little -1. So that's the inverse of A. And when we multiply the matrix A by its inverse, the result is the identity matrix I. And when we multiply the inverse by A, we also get the identity matrix I. Now in this case, we're going to be dealing with 2 by 2 matrices, so the identity matrix would be 1, 0, 0, 1. So whenever we multiply a 2 by 2 matrix, such as A, by its inverse, we will get 1, 0, 0, 1. And likewise, when we multiply the inverse by the matrix A, we also get 1, 0, 0, 1. So that's what an inverse matrix is. Let's see how we would find one. So if we've got the 2 by 2 matrix A, which is A, B, C, D, and we want to find the inverse matrix, what we do is we do 1 over AD subtract BC, so we do A times D and subtract B times C. And if you watch the video on Corbettmaths, the determinant of a 2 by 2 matrix, that's the determinant, and that'd be a really useful video to watch. So you do 1 over the determinant of matrix A, or AD minus BC, and then you write the matrix D negative B negative C A. So you swap these two elements around and you change the signs of these ones. So for instance, if this was positive, you make it negative, or it's negative, you make it positive, and the same with this one. And you swap these two around. So that's how you find the inverse of a 2 by 2 matrix. Now one thing to point out is not every single 2 by 2 matrix will have an inverse. Some 2 by 2 matrices are what we call singular 2 by 2 matrices, and they will be matrices where the determinant is equal to 0. So if you do A times D and subtract B times C, and that's equal to 0, because then that would give you 1 over 0, and that matrix wouldn't have an inverse. So if you work out the determinant of the matrix and you get it's equal to 0, there is no inverse for that matrix. But if it's not equal to 0, it will have an inverse. Okay, so that's how you find the inverse of a 2 by 2 matrix. Let's have a look at some examples, because that looks quite complicated, but when we look at some examples, it's actually quite straightforward. So here we've got the matrix P, and it's 5, 1, 8, 2, and we want to find the inverse of this matrix P. So the inverse of this matrix P, so that would be P -1, like so, will be equal to 1 over, and then we work out the determinant of this matrix. So we do A times D subtract B times C. So let's work out the determinant of matrix P. So it's going to be 5 times 2, so it's going to be 5 multiplied by 2, subtract 1 multiplied by 8, subtract 1 multiplied by 8. 5 times 2 is equal to 10, subtract 1 times 8 is equal to 8, so we've got 10 take away 8, and that's equal to 2. So the determinant of matrix P is equal to 2. So for the inverse matrix, we're going to write 1 over 2, 1 over that determinant, and then we're going to write the matrix D negative B negative CA. In other words, we swap these two elements around, so we're going to write a 2 here and a 5 here, and we're going to change the sign of these elements. So it was 1, so we write -1, and it was 8, so we're now going to write -8, and then that's it. So the inverse matrix would be equal to a half times by 2, -1, -8, 5, and that's it. Now you can, if you want to, multiply each of these elements by a half, so we could write P -1 is equal to, and then multiply each of these by a half, because it's a half outside, so a half times 2 is equal to 1, a half times -1 would be -1/2, a half times -8, well a half of -8 would be -4, and a half times 5 would be 5/2. So you could write it like that if you wanted to. I probably would just leave it like that. Okay, let's have a look at our next example. So next example, we've been given the matrix A, which is 12, -4, 2, 1, and we want to find the inverse of this matrix. So the inverse of this matrix would be A -1, like so, is equal to 1 over the determinant of this matrix. So let's work out the determinant. So the determinant of A would be equal to A times D, so it's going to be 12 times 1, subtract B times C, so it's going to be -4 times 2. So we've got 12 times 1, that's 12, subtract, and then -4 times 2 would be -8. So we've got -8. So we've got 12, take away -8, which would be 20. So the determinant of this matrix is 20. So for the inverse matrix, it would be 1 over 20. And then what we're going to do is we're going to write the matrix where we swap these elements around. So we're going to write 1 and 12. And we're going to change the sign of these two, which means we're going to multiply them by -1, really. So we're going to change their sign, so it's going to be 4, and that's going to be -2. And that's it. So the inverse matrix would be 1/20 multiplied by 1, 4, -2, 12, and that's it. Now if we wanted to, we could multiply each of these elements by 1/20, so we could write the inverse matrix would also be equal to, and then multiplying these by 1/20, 1/20 times 1 would be 1/20, 1/20 times 4 would be 4/20, -2 times 1/20 would be -2/20, and 12 times 1/20 would be 12/20, and we could simplify those to be 1/20, 1/5, -1/10, and 3/5. And that's another way of writing the inverse matrix. Okay, let's have a look at our next question. Okay, let's have a look at one more example. So we've got the matrix P, which is -3, 0, 10, 2, and we want to find the inverse matrix. So let's find the determinant of matrix P to begin with. So the determinant of matrix P would be -3 times 2 subtract 0 times 10. So it's going to be -3 times 2 subtract 0 times 10. Now, -3 times 2 is -6, and we're going to take away 0 times 10, which is 0. And -6 take away 0 will be -6. So the determinant of this matrix is equal to -6. So the inverse matrix would be equal to 1 over the determinant, so 1 over -6. And then we would write the matrix, would swap these two elements around, so 2, -3, and we'd change the signs of these two, so 0 is still 0, and 10 would become -10. Now here we've got 1 over -6, so I'm going to write the inverse of P is equal to -1/6, and then 2, 0, -10, and -3. So that's one way to write it. Also here, if we didn't want the negative sign here, what we can actually do is change the signs inside the matrix. So we could write the inverse of P is equal to, so multiplying these by -1 would leave us with, well, here we would have a 6 outside, and then timesing all these by -1 would be -2, 0, 10, 3. So we can write it like this or like this, and that's probably how I'd leave it. Alternatively, you could multiply these by a 6, and that's it. So in this video, we've looked at how to find the inverse of a 2x2 matrix. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.